Okay, so, all right. So again, we're doing mean hypothesis testing, and one of the big takeaways for us is uh, whether or not we know the population standard deviation. If you know the population standard deviation, then you're going to be doing a z-test. If you do not, you're going to be doing a t-test. So this line right here, assume population standard deviation is 1.07. This is my indication that I'm going to be doing a z-test. So I'm going to be doing a stat, a z-stat, one sample, and this is with summary. So this is what I'll be doing eventually. Okay, so z-test because of the population standard deviation being known. Okay, now when we do the first question, the null and alternative hypothesis, the top is always equal, so you can rule out D, you can rule out E, you can rule out C, you can rule out everything actually except for A. That's the only one where the other one's equal. And then it says something about the claim is 3.3 per year. So the sample was 3.3, and then the what the heck? Why doesn't it let me check answer? I may have been kicked out. Check answer. I've been logged in for a long time though, like half an hour, so I may just have to like log out and log back in. Sadly. So sorry. Let me go back and just open StatCrunch again. Really? Oh, that's odd. Well, I'm just gonna open the stat again. Sorry about that. I've been signed in since like 3:30, so I just assumed I timed out somehow. I've never seen that before where it wants the answer to part 2 before the answer to part 1 is given. I've got so many tabs open at this point. I need to close some, otherwise this is just going to freeze on me. Okay. Back to module 5 homework, back to, all right, I'm going to question 7 again, just to, open StatCrunch. Okay, so we go to question 8. Okay, so we think it should be A. And again, we want to do z-stat because the population is known, one sample, and with summary. So we were already there, so hopefully that's not a big deal. The sample mean given is that 3.3 number. The population standard deviation is 1.07. And the sample size is 60. And then we want to, for me, I want to copy A. So I want to say that I'm equal to 3.4 and then not equal to 3.4. And then just compute. I think we're doing the hypothesis test. So my z-stat is negative 0.72. Yeah, 3.3 is the average from the sample. And right up here at the top, the claim is that it's 3.4. So we're testing against, I put as my sample mean 3.3, and my hypothesis number is 3.4. Because the claim is that the population sample is 3.4, or the population stat is 3.4, and we're using this sample to see if we got something unusual or not. Oh, Ashley, I see why it's not letting us do anything. It says 0.0 of 1. So it's counting this all as a 1-point question. So basically we have to answer all of them all together before. So that's why. Normally this would be a 4 or 5-part question, a 4-part question because there's part D, but it wants us to do it all at once. So 3 decimal places, mine's 0.469, which is a fail to reject. Fail to reject is not sufficient. So that's D. Fail to reject, not sufficient. And then I'm ready to check. This one says fail to reject and is sufficient. So that's the difference. Okay. So tough skating on that first one, but we're through it. And they should get easier now. What's that? Okay, so now we're on a 2 sample. And because we have S is sample standard deviation, which means we're back to like the world of doing t-tests, not z-tests. So T is in Tango, not Z is in Zulu. So stat, t-stat, 2 sample, and then this chart is giving us summary data. Of course, the annoying part is it gives it in like wrong order. So like 2.38 is the first number for me. Standard deviation 0.95. Sample size 28. The next one we have 2.69. 0.66. And 37. I'm just filling all that stuff in. Before I'm actually looking at what's happening. So the claim is the 2 samples are from populations with the same mean. So that means equal on top, not equal on bottom, which is C. So let's go ahead. We have equal and not equal here. And again, notice this says mu1 minus mu2 equals 0. That's the same thing as saying mu1 equals mu2. You would just add mu2 to both sides. So we can compute. This one is in 5 parts, so it's different than the last one. So we just check each part independently. T-stat is minus 1.48 for me. P-value 0.146. And then we're comparing to 0.05. So again, this is a fail to reject with not sufficient evidence. Okay, so the fail to reject is sufficient as D for me, not sufficient as B. So I need B. Okay, so now it wants us to do a confidence interval. So don't start from scratch, just go to options and edit. And then you just want to change the dot from hypothesis test to confidence interval. And it's going to be dependent on what the significance level is. So because mine is 0.05, my level needs to be 0.95. They always need to add up to 1 or 100%. So I compute that. And then I'm just entering lower limit and upper limit. And it says 3 decimal places, so I need to make sure to do that as well. So negative 0.7 323 and 0.112. Which aligns with our notion of fail to reject because it contains did I round wrong? What happened? Oh, I did 4 decimal places. I typed a 4th decimal place on the first one. So it's really picky. So you have to type exactly 3 and round appropriately. Okay. On this one, you need to click the little thing, and then we're going to enter this. Again, we're in a 2 sample. It says S, so that's t-test. So I'm just going to do options edit because it's exactly the same kind of test. I just need to change all the data in my chart. So let's go ahead and try to do that. Okay, so sample mean, that's the X bar. For blue, that's 4.09. For standard deviation, that's 0.58. For sample size, that's 36, that's N. And when we do sample 2, sample mean is 3.31. Standard deviation 0.83. And then N for the last one is 40. Okay, so I'll pause for a second because I know everybody. Oh, and remember to go back to hypothesis test because we just did confidence interval for the last problem. I know everybody's numbers are different than mine, so I'll give you a second to catch up. Researchers make the claim that blue enhances performance on a creative task. So to mean that means blue should be greater than is what we're testing. So test the claim that blue enhances. Notice that we're doing a level of 0.01, so it's a small significance level, which means the confidence level needs to be 0.99. So we need equal and greater than. Okay, so the hypothesis test equal, make sure to switch this to greater than. Okay, so whenever it says less than 0.0001 like that, we're allowed to just type 0 for the p-value. For the t-stat, I get 4.79. And then the p-value, you can just type 0. So whenever you get 0 for a p-value, you're rejecting. And when you're rejecting, that means there's good evidence for the alternative hypothesis, which means blue is enhancing. I didn't even really read what we were studying. Oh, the effects on creativity. Red background versus something like that. So we're rejecting, and that's giving us good evidence. So reject is sufficient evidence is all you really need to look for based on how we break these things down. There was a time in graduate school where like I read some studies like this, and they said you were more creative if you used online paper, and I was doing like, math research at the time, and they said it was better committed to your memory if you used like a yellow paper. So I was like going to Staples buying Unlined Canary copy paper to do all like my notes and homework on. I mean, I graduated school and did pretty well, so maybe it worked, but maybe it was just snake oil. Okay, second part, options edit. We're just going to a confidence interval, so just switch from here to here. We have to be a little bit careful because it's a one tail. Strictly greater than. I think I'm still just going to do 0.99 because originally the thing is 0.01. If I get it wrong, we'll switch to 0.98, but this looks okay. 2 decimal places, I get. Did you do 0.99? When you went to part A, does it say 0.01? So you're gonna have to scroll up and see what. Okay, so let's try 0.98 because this is one-tailed. That's usually what happens on these. Remember, you have to double the error when it only goes one direction. So greater than is only on one side of it. So let me try 0.98 first, Ashley, before you use another attempt, just to make sure that that was actually the problem. Yeah, so that was it. So just go ahead and switch to 0.98 and you should get the right answer. So on one tail, normally, so when you have greater than or less than, you need to double that significance. So that's all that I did was I took this 0.01, I doubled it since we only had one side rather than two. So the significance level has to be twice as much because it's only on one side. So it's 0.02, which makes the confidence 0.98. These two numbers, if it were 0.02, then this would have to be 96%. They always have to add up to 1. But if it's one-sided, like greater than or less than, then you have to double this number. And then whatever that is has to add up to 1. Do you follow? Because 0.01 and 98 add up to 0.99, but 0.02 and 98 add up to 1. Is that still confusing? Yes or no? I can write down like a flow chart of like what you're supposed to do in these scenarios. Oh, okay. Sorry, I just can't. I didn't want to pop back up to here to see the thing. Yeah, basically, there's just two cases. Yeah. All right. So if your confidence interval contains 0, then that's fail to reject. If it's only positive or only negative numbers, you're rejecting. So this is only positive numbers, 0.39 to 1.17. There's only positive in theirs. So that means not sufficient evidence. That means is sufficient evidence. Excuse me. When you reject, you have sufficient evidence. So fail to reject, not sufficient evidence. Reject is sufficient evidence. So sometimes you have so many negatives being thrown around, like is insufficient, not, is not, does not, stuff like that. It can get confusing, but okay. These ones, notice that we have the same number of data values. Like if we looked at this previous problem right here, we had 36 samples and 40 samples. So like we were comparing the samples, but we didn't have the same sample sizes. We have a special kind of test we can do when we have the same amount of data. And this is called paired sampling. So we can basically pair each of these. Because like this is probably like best actor and best actress of the Academy Award in each specific year, if that makes sense. So we can naturally pair them up. So what you want to do, again, is just close your StatCrunch and then use this little double rectangle box to open it in StatCrunch. And so now for this one, you do stat, tstat, and you go down to the one that says paired. Because there's exactly the same number of sample sets. And another indicator is that if it has mu d like this, that means paired. So we just drop down actress column 1, actor column 2. And then we have to look for claim. Is it saying greater than, less than, or just different? What is the claim? Test the claim that they have a mean less than 0. So we want to do equal to 0. It's always equal on top. And then we want to do less than 0 on bottom. And then we want to do the same thing over here, equal to 0 and less than 0. And then check answer. And then do our tstat. Minus 2.76. 77. I was rounding wrong. Excuse me. My 8 bumps the 6 up to a 7. P-value 0.011 if I round. Okay, 0.011 is pretty small, but I don't know what our significance level is. Oh, 0.01, it's slightly bigger. So the p-value is greater. So we fail to reject, which means there's not sufficient evidence. It was really close on mine. I don't know if yours was really close or not, but 0.011 is just 1,000th bigger than 0.01. Any questions there on number 11? Oh, we got to do confidence interval. So 2 more parts. So edit, and then just go down to the bottom. Okay. Now on paired, I can't remember if you double it still or not. I think you do, since it's one-sided, right? Because when we did our hypothesis test, it was less than 0. So instead of 0.99, I'm going to do 0.98. And then try that. So I get negative 22.0, and then 0.21. Okay. So for whatever reason, when you're pairing it, you don't double it. So I thought that was the case, but again, I can't exactly remember why that is. For a paired value, you don't have to double it the way you do when you don't have paired. P-value is under hypothesis test. Are you doing confidence interval? So you're going to have to go back and just go options edit if you forgot that part and go back to your hypothesis test. Yeah. Yeah. So the confidence interval part is always just, entering 2 numbers and then seeing if it includes 0 or doesn't include 0. 1 decimal place. That's another thing. Decimal places can get you. Yeah. Try again. Okay, so -3. So maybe I was right with 0.98, but maybe I did wrong decimal places and didn't realize it. So if I double it, I think that's what I did. I think I messed up decimal places. I think you still double it because it's just great, just less than. So 22.0 and 0.2. I think I did 0.21. I think that's why it marked me wrong, because it says 1 decimal place. And I think the first time I did 0.21. Yeah. Okay. So you still double it. The rule still applies even if it's paired. Since it was less than, I doubled 0.01 to 0.02. But yeah, I remember this being a tricky part. Like, they really love to just switch your decimal places. 2 decimal places, 3 decimal places, 1 decimal place. And it's super specific. So it gets really annoying. And if you're not watching how many decimal places they ask for like a hawk, you can spend a lot of time just having to run these again. Okay, so I have a negative number and a positive number. That means I include 0. And when you include 0, you fail to reject. Okay, so we're on another paired example. So again, you don't want to do options edit here because this is a data example. So you want to close out and populate using your little double rectangle. Okay, so stat, t-stat, and paired. 6 parts, lovely. Okay. What is the claim? Greater than. So we're still in a one-tailed because whenever you use greater than or less than, that's one-tailed. Not equal is double-tailed or two-tailed. So we want to do equal, 0, and greater than 0. And our t-stat is how many places? 2. Mine would be minus 0.24. The p-value, 3 places for this, 0.5899. 9 bumps up, so 0.590. I had to do a little carrying in my head, so the arithmetic was even tricky. All right. So what's our conclusion? That's a gigantic p-value. So we're failing to reject. It's got to be greater. Got to be failing to reject. So that's not sufficient evidence. Are you guys starting to feel the hang, hopefully, of how these go? Like the concluding part, no matter what kind of hypothesis test we do, always kind of goes the same. Less than, reject, is sufficient. Greater than, fail to reject, is not. So those two paths always happen. All right. Now we want to do a confidence interval. So we edit, just go to confidence interval. It says 0.05. So if you double that, you go to 0.9. And we double it because it said greater than. So 1 decimal place, that tricked me last problem. Let's not let that happen again. 9.4 minus 9.4 and 7.4. Okay. What feature leads to the same conclusion? Well, a negative lower limit and a positive upper limit means it includes 0. So fail to reject. Okay, we've got some more paired. So I'm going to close and then open again. Anyone having any problems? No? Okay. So stat, t-stat, paired, column 1 daughter, column 2 mother. Okay, test the claim that there is no difference. So that's equal, not equal. So this is the classic two-tailed. That's beautiful. We just use the numbers they give us so we don't have to do any doubling of any kind. So we can compute and check our answer. Our t-stat here is 0.73. And our p-value is 3 places, 0.482. Later in the semester, like on the very last one, like when we're doing ANOVA hypothesis testing, there's one that's super annoying. It asks you for 6 decimal places, and then it asks for 4 for like the second part. So like you'd like get dyslexic just trying to read all the numbers off. Okay, this is again a gigantic p-value, so that's greater than any normal significance level. The biggest significance level you'll ever see is 0.1. So we do not reject, which means there is not sufficient. Okay, and we're on our last question, which is just a confidence interval. So that's lovely. Scroll over, and then we can open that in StatCrunch. So this one, we just go directly to the confidence interval, which is great. Not too many parts, just 2 parts. Let's see if it has any trickery, though. Again, we see the keyword paired sample data. So we're doing t-stat paired. Yeah, I think we just use 95 when it says construct 95. Yeah, if it tells you the number, you just use the number it tells you. So I don't think it's allowed to. So if it's basing it on the significance level, you have to do that creative work. But if it doesn't, if it just tells you the confidence level, you're using the confidence level. So if this were one-tailed, that might mean like something like 2.5% or something crazy. So that's probably why they don't do it. 0.84 for me and 1.94. Okay, so maybe we do. Let's see. Um, oh, I did 3. Again, usually it's just a decimal error. I typed 3 places. I didn't hit my delete key. Okay, so I got it right. Does it appear to be effective? Okay, well, it should work. Check that what you typed for your lower limit and upper limit. Well, it's got to be syntax because mine did. So you opened it and then you did a confidence interval. Yours says 95% specifically. So let's go through the steps. You open it, you do stat, T stat, paired. We do confidence interval. Does yours say 95%? Okay, compute. I forgot to do my columns. Did you do your columns backwards possibly? So I get, okay, what's your third number though? On your L limit, what is your 0.7 whatever? That's it. So 0.706 would be 0.71, negative 0.71. Okay, so how about your upper limit? So 2.25, okay. And you put both those in, you checked, and you used the negative, and you did the negative sign also? Any chance you can share your screen just so I could look? Okay. Okay. Well, try to get the second half right at least, so you get like a 95 or something. Yeah, so you get the half point, and then so does it appear to be effective? No, because it includes 0. Okay. Let me just end the recording real quick. Wherever that is. Stop recording.